that is different from functional programming, object orientation programming, or procedural programming. And then also a prompt orchestration framework for LLMs. Because like right now, there are just a lot of these local LLMs that we can run. And they're getting better, they're improving. The different companies are releasing them, they're open sourced. So I think the future of LLM will not just be like GPT-4, OpenAI or Anthropic. I think it will also be a more bigger communities where people can just run LLMs in their local machines and then get things to work. Yeah. So let's begin the talk. Here's the introduction. So 5 years ago, I was studying programming language theory, and I give a talk about programming languages at GeekCamp. So that was 5 years ago. And this is a little bit like a continuation of this talk as well. So I'm just going to kind of go through where I left off 5 years ago. So in general, if you look at programming languages, actually the most obvious thing is that they are not designed for humans, because they're always designed for compilers and interpreters. This is why, actually, I think this is the gap between a non-programmer and a programmer. So a programmer is really just someone that can simulate a compiler or interpreter in their mind, so you can write a code that is syntactically correct and then get it to work. Meanwhile, a non-programmer, you look at the code and you just feel like So it's like when I started programming, I started learning programming when I was 12, 13, and I just couldn't get it. It took me 2-3 years by reading all these books in library to finally write my first line of code. So I think the separation is between programming languages and between programmers and non-programmers is really that programming languages are not designed for humans. So one illustration is that, let's say we do factorial. So meanwhile, if you write a program, you end up writing all these pieces of things that look like they're doing a lot, but really they're just performing the simple operations of multiplication that you can explain to a child. So the reason why programs looks like this is because, first of all, we need to do tokenizations. So this is kind of this is from my talk 5 years ago. Yeah, just using the slides. You need to do tokenization, and then you need to parse them into abstract syntax trees, and then so that now when you run it in a microprocessor or a interpreter, it can understand it, or you compile it to a low-level code. Yeah, but in human languages, we cannot do that too, right? It's like English or Japanese or even Chinese, we have syntax and grammar. So they are actually not that far apart. So what would be a programming language designed for humans look like? And that's really, I think that's the questions that we need to think about in the next 5 years as LLMs improve. And I think if we can embrace fuzziness somehow, then we can open up to a lot more possibilities if the programming language can embrace fuzziness. But the interesting thing is, if you ask the mathematicians what programming languages do they use, they will tell you that it's graduate students. That is because graduate students, they can embrace the fuzziness the way that everyone can, because we are humans. So deep down, what a programming language that's designed for humans looks like with just words. And what's interesting is, if you look at our life right now, in this human civilization, we've discovered that if the input of something is the culture, the social norms, financial contracts, laws, arts, then we don't need software engineers. Humans will just parse them and understand them and create routines, and this is how you build a society. So deep down, software engineers, we are more like middlewares. And in this sense, that means it is only when the task of the middlewares, the task of software engineers, are really just to create these computing systems to enforce and extend existing inputs, that cultures, social norms, and financial contracts, blah, blah. So it's like, if I give this talk with paper and pen, I can do that, and then I withdraw this. But now I have a program to do that for me. So now the middleware, which is software engineers, will be invoked to create this program. Oops. Yeah, now I need to invoke some technicians to help. I don't know what's going on. Yeah, anyone can help? Are you technicians? No, but this is using AirPlay. Yeah, I don't know. Yeah, Yep. So that's the talk. That's okay. Yeah.
We need to get the guy in.
Okay.
I don't know why that thing was.
Yeah. So anyway, later it's gonna have a little demos. I'm gonna demo. So anyway, I'm just gonna continue with our slides for a bit. The point is really that if you can program in natural language, that will open up a whole new world of possibilities, as everyone can, just make apps that you can use in everyday life. In order to do that, of course, if you have a programmer, you can tell the programmer what to do, and then he is going to correct you on some technical things that you have not foreseen. So in some sense, it's like it's going to be an interactive process. But the question now is, how can we make this interactive process with ChatGPT, for example? So instead of a programmer, you get ChatGPT to code for you. And how can we make this process more structured, but still use natural language so that you can still say, okay, I want to make this button, I want this work. And it's actually going to look at the existing code base, look for the relevant things, and to replace it for you. And this is what the framework that I'm developing is trying to do. Yeah, so, and this is in the process known as prompt-orchestration. So, so when you use ChatGPT in the OpenAI website, it's really just a client where they're using like all the past histories of the chat as prompt. But there are actually many ways to compose prompts and to do prompt orchestrations that are much more like complex and complicated than using the ChatGPT client on the OpenAI website. Oops, so I'm still not getting the AirPlay. Okay, yeah, all right. Oh yeah, this thing just come down. I thought it's like AirPlay is ready. Yeah, but anyway, so let me see. Oh yeah, maybe just want to ask some questions. Oh, can I have a show of hands? How many programmers are in the room? Oh, great. So it's like 70%. Okay, that's good. Yeah.
Sorry, hold on while we figure out the projector.
And can I have a show of hands? How many of you guys like to write functional programs? It's not everyone. Okay. And I see. And any web developers or mobile app developers? All right. Yeah. So my focus now later on is going to be more of web and app development. But of course, this framework, if it works, it will work across any code base. And so I'm really curious about how this will work with like Rust or with some things that is more memory intensive or even a lower level like C. But yeah, maybe I'm just going to give a little summary of how this prompt orchestration is going to work since the slides are not ready. So if you look at every program, as you write the program, one of the things that a programmer actually depends on the most is the language server. Oh, this is the light. Is there a way to brighten? Hey, it works. Okay, cool. Where's the mouse? Cannot find the mouse. Oh, wait, it's a keynote. There's no mouse. All right, yeah, okay. Okay, so yeah, okay, go backtrack to the slides. So programmers are middlewares, and we live in the human civilization, right? So now, the interesting thing about the past 20 years is that because there are more consumers, we are using these devices. So basically, the code that programmers write are reshaping the way many systems in society work. And just before I get to the LLM, I just want to share with you guys this super cool domain-specific language that basically mirrors the legislations or like any kind of law and does the mathematics. So, and what's the cool thing about this is like, basically with GPT-4, actually, by just writing this, it can generate this like 90% accurate at the time. So it can do like text, can work with text laws, I don't know, maybe it's like criminal laws. So you see how you can calculate how long the guy's sentence is, I don't know. But yeah, but so this is like, yeah, so this is like a domain where we don't, I think we have not seen anything like this in the past 5 years. So this is the research, it's ongoing research. Yeah, yeah. So eventually, if we can automate, like let's say laws, and then if you can automate many different systems of regulations, and then we can actually gradually remove the human elements from it, and I think eventually we will have probably either semi-autonomous or fully autonomous government. I think in the next 40 years. So yeah, and I think can be a good thing. So yeah, now, so yeah, back to the programming paradigm. So what will be a new programming paradigm looks like? And I think we need to answer the following two questions. One is that computationally, you know, what exactly is an LLM? So you see it working, you see that is interacting with humans, but what exactly is it from a more conceptual perspective? From a programming language perspective, what is the LLM? So that's the first question. I will get back to that later. And the second question is, what problems can we solve with these new paradigms? So yeah, how can they be better than the existing ones? Yeah, and so now is a bit of a demo. Yeah, just, oops. Okay, and this is kind of an unfinished demo, but so the way this works is that basically so it's supposed to actually show you all the files in a repositories. So you can open this app on any existing code base, and what it's going to do is that it's going to do parse the code and do vector embeddings on different structures of the code. So and so later on, the thing that I still haven't managed to do is to auto-generate categories. But the idea is that let's say you have a code base of 100,000 lines of code. So basically, categories are just abstract concept that it could be like UI. You can just write anything, and what it does is try to because all the code is encoded in the latent space. So it's basically every category, when you click on it, it's going to look for the most relevant code to this word semantically. Yeah. And so, but that part is not really done yet. But anyway, I'm just going to show a quick example how this works. So it's like, let's say you have a programming task. The task could be like, let's say this is the post, post, and then you say, I want to implement a button that assigned a new users to the post, right? So after you write that, you can edit existing post, and this is so this works across any file, and basically it's just going to take this and look at the existing files as well as all the relevant pieces from the other code and generate this for you. Yeah, and of course now it's like, so this is edit existing, and you can also create new file. And if you create new file, then it says, okay, yeah, you need an assign user button. So it will create that for you. And the part that I have not finished yet is basically to have a button here where you can say, yes, create this, and you write to your code base, or you can say some things like, have this. So instead of generating a file, you could generate, let's say, a snippet of let's say, a property of a class. So instead of doing like manual, like copy and paste, by analyzing the abstract syntax tree, you can actually just like inject to the most relevant, like the positions. Yeah. So that's the part is not done yet, but in general, so another part is going to happen is that there going to be another button here. Let's say it's like next. So if you could click next, it's going to find the next relevant file. So it could be a post, right? This is the Prisma. And then now you can say, okay, oh, no, you can say create a new file, right? And then now, yep, it's gonna create a file for the, oh no, I think now it's edit, yeah. But basically, yeah, now it's gonna like tell you, okay, yeah, you need a new data structure for the file as well, yeah. So basically, what's happened behind the scenes is that I can show you just a little demonstration of the abstract syntax trees, yeah. So there's kind of a parsing happening here, and so if you go to your code base, you can create this like comment to mark this as something that's important or something that's working on. And this will basically give you like a more importance scores in the prompt orchestration. So yeah, and so basically, yeah, pass this in the abstract syntax tree, and then the vector encoding, the way it works is actually going to encode the first thing first, encode the whole chunk, and then encode this part, encode every small part based on the how the abstract syntax tree works, and yeah, and of course, what you can do is also basically you can have like another fish here, and then do some kind of like a separation. So let's say you want this to be to be like a segment that is like useful for you. So because if it's just a normal abstract syntax tree, it's gonna break down into a lot of different pieces. So another feature that this framework has is that you can tell them, oh, this piece of code, yeah, they work as a whole. So don't break them down. And so when they encode this to the latent space, it's going to take the whole code. Yeah. And so, yeah, and then later on you have, so this is the code base that you're operating on. And then basically you have, basically you have so this is like the source code of the framework of ArchGPT. Basically, that's parsing, and then you have a DB, and then it's gonna like calculate the So it's like you're gonna do the ranking of the segments of files, and you can have and random based on the category. So you define category, and it's also gonna get encoded into the database, yeah. And so if it works, then there could be another button called autonomous, where it's just going to like perform this task and look for different files. And so I feel like the end result is going to be basically like every programmer is so tired at the end of the day. Now you have some features to implement, but you're going to sleep. So what do? You take this up, you say, just implement this, you know. And then you get it to do it autonomously in your local machines. And then the next day when you wake up, you can see like the code you write, and you see like which part need to be edited or like how it works. So it's a bit like code farming. And it still requires you to like debug in terms of the segmentations, or in terms of like telling it which, like just now the fish notations, telling which piece of code is more important. And then there will be more like tagging features as well. And of course, if you write great code, then this will work well. So it also depends on how's your code. Yeah. Now, so sorry I can't give you a full demo today, but I'm open sourcing all the parsing and the npm package, so you can install it and try it out. It use the LensDB, and yeah. And anyway, so the overview is that basically you have all the code in the code base. So you go to abstract syntax trees, and after that, through pruning and encoding, you go to vector embedding, and then after that, and vector, yeah. So this is the part that I think is quite interesting from the point of view after working with LLMs for 3 years. So I think so. It's like I think right now many people working with GPT-4 and 3.5, there's many things that they don't see because they have not tried GPT-3 or GPT-2. So it's like back in GPT-3, GPT-3 for example, just one simple illustration of this. So back in GPT-3, let's say you have, oops. Oh yeah, here. So back in so this is something that, as I was working with GPT-3 in my previous company, one of the things that is super weird for us in the beginning is that, let's say we have this as a prompt and we want to generate something. If there is a like a mismatch of characters here, GPT-3's performance actually drops like crazy. So it's like, for us humans, this is kind of strange because it's still the right thing, but it makes sense too, because GPT-3, you need to, I think in the end of the day, we should look at everything from GPT-3's perspective when we work with LLMs, or from an LLM perspective. And so the way it works is that all these are going to be encoded into long strings, and then you're going to feed it into transformers. So the difference of having a space here for GPT-3 is a huge matter. It's kind of like, so the way I look at it is that LLM works by creating by encoding relations into the structures of the code of the sentence that you write, into the various structures. So is also one example. In GPT-3, if you do this, you put ID here, in many cases, it could actually have worse performance because it normally don't see ID at the last field. That's like, of course, it also depends on the code you read. Yeah, so eventually, I think, so eventually this is something that in GPT-3 or GPT-3.5 or 4, it just disappeared. But it's still actually making the mistakes, but it's just that now maybe the performance dropped from 99% to 98%. Yeah, so most people don't really know. But by just putting the code nicely, it has better performance. And this is also why when I was working with GPT-3 and 4, the best code to work with is Haskell, because the way that every piece is put together, it somehow just like more resonate with the way that the LLMs try to retrieve information from these structures. It's just more clear, right? Because it's like the same code when you write in the same code you write in Python, you write in Go, to do the same thing. They all look kind of different, but if you write in Haskell, it's either gonna use this class, this type, and then it's gonna like look like that, or it's gonna look like this. And so this actually helps the LLM to have a better performance. Yeah. And so back to the so back to here. So the better embedding, basically, this is the transformer. It uses the structures in the text to give you LLM abstractions. And this is the thing that I think is going to be mentioned a lot in the next 5 months. But yeah. And so it's like the whole notion that how we basically how does LLM manage to work with all these fuzziness that humans can work with. And it's also LLM abstractions. And that also means if you talk to LLM about something they have never seen before, yeah, it just, or basically it's a category that it doesn't understand, then yeah, it's not going to work. Yeah. But of course, the cool thing about abstraction is also like the way things can get composed. So if you talk about quantum mechanics and then you talk about something like some category that can somehow combine with it, and then it can actually make sense. But when you do that, you can see how LLM, let's say GPT-4 for example, you can see how it's really just it's doing it in a very naive way when you combine these concepts these abstractions that I've not seen before. Yeah. So in the end, yeah, we perform the prompt composition on a subset of the code base, and I call this category by Euclidean distance because when we look at vector embeddings, they are in a latent space. So to look at the similarity, yeah, we basically measure the Euclidean distance. It's kind of a clustering, yeah. And so, yeah, so I think these new paradigms, because it largely uses natural language to transform a code base. So I call it the category as a first-class citizen instead of functions, objects, and procedures. Yeah, it's central. Yeah. And the interesting thing is, if you look at category theory, this is known as the most important lemma in category theory. So it's like one of the greatest finding, because you can so this is like a lemma that is a generalizations of other statements in different branch of mathematics. So in group theory, there was this theorems about how every group is isomorphic to a subset of a symmetry group. So this is like a generalization of that, and it just says something super straightforward. Then everything in a category is completely determined by its relationship to everything else. Yeah, and this is, I feel like, as non-programmers or as non-mathematicians, we really need to we should appreciate that this a lot more, because this also talks, you can also apply this to look at societies, to look at human interactions. So there's a saying that says like you are the average of all your friends, or something like that. It's like, by knowing the relationship of you with everything in this domain, then I kind of know you. Yeah, so that's what it says, and that, I think that's what the, when you have a category as a first-class citizen, then that's something that we can try to see how we can apply this principle to design these paradigms, or to design this framework. Yeah, and so I'm going to end this talk by saying that, so the things I'm working on now is a fork of of a famous API client, and it got popular recently. So, but it has 300,000 lines of code. So every time when I try to maintain this piece of software, I have to search through all the code. I have to search through like 500 files, and then so let's say I want to implement new features for the database, and then it's like, actually the process is quite straightforward. I look for this class that is being used, I extend it, add a test case, or add a new component. But when I'm going to do it as a human, yeah, it just feels like, it actually makes me feel like I'm a machine, you know, because I kind of have the idea what I want to do. So I think one of the applications of this paradigm is that I can, so that's the thing I'm working on now, is to encode these 300,000 lines of code into embedding, and then get this framework to implement things based on the relevant files, and then try to see if, so the future could be like, you have this LLM just look at the GitHub tickets, and then you just try to implement it and do a pull request. Yeah. So what's next? I think this is next. So this is like research by MIT 4 months ago, and it's really, so it's kind of a proof of concept, but the idea is like, it's actually possible to create machines that assemble a part to build the machine that is basically itself. And I feel like if you don't do this is like another kind of Moore's law, but it's actually better than Moore's laws, right? It's like, if you don't do this, I don't think we can ever like have another lead of technological advancements. So I think the futures of software is machines that build themselves, and user experience that fosters mindfulness. And so, yeah, thank you. And that's the talk. Yeah, let's do a Q&A. That'll be nice. I would really love to hear feedbacks from any of you, or what do you think?
I would learn, right? Like if let's say I want to run this instance on like my local machine, what are the recommended like RAM and processors does the computer need in order for it to run smoothly? Because I know like when you run LLMs, they usually like require a certain amount of computing resources, because since this is your area of expertise, you can actually give like the recommended requirements, recommended hardware requirements to run.
So this is pretty cool. This was actually released 1 week ago, less than 1 week ago. So this is called Mistral AI 7, and it's 8 billion parameters, which means you can run with like 16 gig, and it's still performing not bad.
16 gig.
Yeah, or less, I think. Yeah, but
does it need GPU?
No.
No GPU.
Yeah, so for Llama, there's a port where they just port it into C, so you can run on CPU. Yeah, of course with GPU it's faster. So all this you can just run on any local machines. Or I think on 8 gig probably can, but kind of slow. Yeah, and yeah, this is like 4 days ago or something, and they just released it. And some of the, in terms of the the performance, some of the tasks, it actually outperforms Llama 132B, but just like small models.
In terms of the hard disk space to store the parameters, how much does 8 billion parameters actually use in terms of hard disk space?
I'm not so deep into the local hosting scenes yet.
Okay.
Yeah, but you can, but there's a lot of good libraries. Yeah, like you can just try out like Llama CPP or Llama. Yeah, and they're doing a lot of optimizations. So that's the cool part. It's like a emerging culture of hacking local LLMs. Yeah.
Okay, sorry, thanks.
Yeah, cool. Yeah.
What's your favorite LLM? What's your favorite local LLM?
Right now, I think for local LLM to work really well, you need to fine tune it. So right now, I haven't really got super great performance. But I do believe, so I believe in the workflow of fine tuning a LLM using examples from GPT-4. And then after you fine tune it, you can just fine tune it for a certain very specific task, like render like React components with Tailwind CSS. Yeah, that's the next thing that I'm looking into. Yeah.
For the recording, can you repeat the question as well?
Okay. So for the question is, so if I didn't, I get it right, is to assemble the data set for fine tuning, right? Yeah. So for that, there are frameworks. So you normally use LoRa, but there are other framework on top of it, and that's the part that I'm not like look very deep into yet, because if you do this with, let's say, OpenAI, it's very straightforward. Yeah, but to do it locally, there are many libraries, and I think right now I'm not the expert in this. Yeah.
Have you used Copilot? Like, what do you think about it?
Yeah, so I think I was a alpha user of Copilot, and it definitely improved. But sometimes, what's interesting is, let's say you're working on this code base, and you see that it didn't like complete this thing properly for you. If you copy and paste your code into like GPT-4's prompt, it actually does better. So I think Copilot, first of all, they're likely using GPT-3.5. And another problem with prompt compositions, actually that's the biggest problem, is that the performance decreases the longer the length is. So Copilot kind of suffering this. And also I saw like a news recently that says that they're losing like $40 for everyone that uses Copilot every month. Yeah, because this thing is just take a lot of like computation power. Yeah. So I think local LLMs can kind of somehow fix this, but then you can't have like an instantaneous result. It could be like you get this to work when you go to sleep. Yeah.
I understand the motivation to use LLM to generate your functions, etc. But you still have to assess the quality of the results of this.
Yes.
So I mean, I'm not a young programmer, but I still enjoy coding. So for some tasks, when I ask ChatGPT something, some other language I don't know, I understand that it's useful for me because maybe I don't want to learn that language, or I just want. But do you still enjoy coding, or do you just want? I mean, from my understanding, you want some LLM to basically automate kind of everything, which is a bit, from my point of view as a human, I understand I'm also optimize, automate stuff, because it's like you say, you click and you go to bed and then you come back, it's done for you. But you still enjoy coding stuff, or you really aim to have an LLM doing it for you?
Yeah, so one of the projects I'm working on now is more like, I'm actually trying to get Haskell to do something great in productions. Yeah, and the way to do that is actually very difficult because of the whole ecosystem is just not as vibrant as existing toolkit, like for web development. So one way I look at this is a lot like basically you get an LLM to write this code based on some things that you give it. It could be Haskell, and then it actually get linked back into another code base. Yeah. So of course, I don't think it will replace the humans engineers. I feel like it's more like a complete some of the tasks that are obvious to us that it can be done. Yeah, and I think I really enjoy like writing code that's nice and tidy and works. But I think in the real world that's also like when Haskell having Haskell in production is also not something straightforward. So I think
Haskell is quite a specific branch of. I know in the world maybe the majority do Java, C++, Python. Haskell is quite a specific language, right?
yeah.
And
Yeah, so I think
because of these niche aspects, that's the usefulness maybe.
yeah, I think it's also like I feel like it's also about functional programming. Okay. So of course, if you do like C, there are many things where you just can't do it functionally. But I feel like with this, maybe you can somehow. So this is kind of meta programming, yeah. So I feel like maybe we can somehow introduce some kind of abstractions on other languages that you can operate on. Yeah. So that's the.
Speaking of functional programming languages, apart from Haskell, have you tried or are you planning to use other programming languages like Lispy kind of languages like Clojure, because it has like a distinct format like the parentheses and stuff?
You mean like?
I'm curious how it performs on those kind of languages.
Other functional languages.
Like Clojure, like
Lisp.
Lispy kind of.
I think the good thing about Haskell is like it's short, and this play well with the token sizes. Yeah, and others, I think the thing is like the more you get LLM to generate things, like the bigger chunk it comes in, the more likely it's gonna to make a mistake. So yeah, another motivation I think for this framework is like instead of having, it's kind of to get it to generate a subpart of this code, instead of like getting it to like generate the whole thing and then it actually just makes a small difference. It does that a lot of the times, yeah.
I think recently there has been research about multi-agent simulations with LLM, so they have to like try like the chat dev in which the LLM creates the game by itself.
Have you tried it? Oh, yeah, I stumbled upon it. I think it's interesting, but I feel like, of course, I feel like that's a very different domain. That's like gaming, and yeah.
But they used it to like create like small mobile applications. So maybe it can be integrated into this thing, and you create like software tickets for you.
So you mean like it runs on the mobile phones?
As in, it will create a mobile application from scratch by itself.
I see what you mean. Right. No, actually I'm not a believer in that. I don't believe I think it's just gonna create very like basic looking things. Yeah. Yeah, I mean, it's kind of I guess also depends. Yeah, depends on how the open source community is getting better and better. So like yeah, there's more like Next.js. You have all these templates, and I feel like the important thing is still to have something that it's like your existing code base. That as the foundation, that would be a lot more solid than like things from scratch. But of course, it's like experimentations. Yeah. Yeah, I mean for production softwares or for software that, let's say, you want to have like hundreds, thousands or millions of people use it. And that's when all this small like UI stuff, like a lot of this code makes a difference. Like when humans write it and you know that this part, you optimize this thing so it load like 5 seconds, load like 2 seconds faster. So a lot of these, when we have an intensive like a crazy code base of like million lines of code, there's a lot of these optimizations that are, some of them could be done with LLM, but I think most of them is very difficult. Yeah, because and yeah, so if you have like you want something that have great performance and have like polished, yeah. That's, yeah. Any questions? I would like to have more questions from different domains. One more, yeah, maybe one more questions.
Okay. So during the talk you mentioned about how like the way that the code is structured, whether you have the lint, whether you have like the spacing, all those things, it will affect the performance of the LLM. So how do we actually like account for those type of randomness in terms of how like the code convention that people use in terms of copying the code, really like like the linting and everything, so that at least the performance will not be so like terrible, like what you mentioned about like for GPT-3.
Yeah. Oh yeah. Okay. Yeah. Thanks for the questions. I think it's a good one. Yeah. So I feel like there was an existing problem in GPT-3, but now with this newer like 3.5 or if you have a fine-tuned CodeLlama, you can kind of solve that. But the best way, of course, is to like prettify the code. So another thing that a pipeline that is gonna be a part of this framework is a lot of linting and prettifying. Yeah. So it's really try to present like it's like let's say you have an object and then you just sort the dictionary based on the it's like some kind of convention. Yeah, that can actually improve performance in small ways. Yeah. Yeah, does that answer the questions, or is it a different question? Or?
No, I think more or less that. I think like because I think like some teams they have a certain preference for certain like linting approach. So like that's so that is the sort of like the more differences.
I see. Yeah, so I think when in this framework, when a code is ingested into the prompt, it's going to be linked, but it doesn't affect the original file. So yeah, that could be good, but I think in general, it also depends on a comment. Yeah, that's another area that I'm not going into today, but yeah, like so if you have this code base and you have a good comment, yeah, this will improve the performance a lot as well. Yeah. So yeah, so thanks for coming for a talk.